I'm delighted that we have that our next speaker is coming. My sugar smashing tools in the way. Roger Byrne, and I'm pronouncing your last name right.
Yes.
So Professor Roger Byrne, who has actually spoke for us before on this topic, probably at our earlier food thing, which a couple of us were at. So I immediately thought of him when this came up again, because one of the most interesting changes between the last time he did this and currently is that so much more has happened in the land of paleobotany and all this stuff at the very small scale things. And so this is really, in a lot of ways, it's very old research that is the most interesting in many, and will lead us in, and maybe you can tell us a little bit about what's going on now in Europe.
Sure.
Or whatever.
Thank you, Michelle. Thank you. Well, it's a pleasure to be here again. As Michelle said, I spoke before to this group. It must have been, how many years ago? A long time. We weren't trying to remember that. But I did enjoy it, and I remember the audience was very involved, very interested, and I'm hoping you will be as well. Let me just give you a little background on my own interests and where I'm coming from. I'm a professor in the geography department here on campus, and I teach courses in biogeography, general physical geography, and paleoecology. And the latter area is my main research interest. I specialize in reconstructing environmental change by using fossils and sediments, generally from lakes particularly, with a view to reconstructing climate change and also reconstructing how people have impacted the environment. Usually, the time period of interest is usually within the last 20,000 years, which might seem like a long time to most of you, but actually 20,000 BP is not that very far back geologically, and of course that was the time when the ice was at its maximum extent, the last full glacial as we call it. And since then, things have been changing in many interesting and dynamic ways. And one set of changes that occurred that are of particular importance to us involved the domestication of plants to begin with, and then later animals, around about 10,000 years ago. And Mexico was one of the 4 early centers of agriculture here. On the map, you can see I've indicated where these 4 centers are: central Mexico, the Andes, probably the northern Andes, the Near East, and South China. Actually, we could include northern China in this as well, I think, now. But it's an amazing coincidence that people started to domesticate plants, and the names below the dates there, notice, are the names of the earliest domesticates, the first plants that people domesticated, at least as we see it in the archaeological record. And all of this then started at about the same time, which is an amazing coincidence that seems to me can't be due to chance, right? There's got to be some explanation for this. Actually, I teach a course on that, and I can't get into all that today. It would take too long, but I am going to focus on what happened in Mexico. And I have listed here on this slide just some of the more important domesticates in Mexico. There are basically 2 types of plants that were domesticated very early, about 10,000 years ago. Annual plants, such as wild maize, or as we'll see, teosinte it's called, wild beans, amaranths, squash, and chili pepper. All of these reproduce by seed and complete their life cycle within 1 year. That's why we call them annuals. The other group, geophytes, get their name from the fact that they develop storage organs in the soil, in the ground. The Irish potato is an obvious example here, but in Mexico you have similar plants that were domesticated here. Jicama, which is a member of the legume family, and probably sweet potato as well. There's some question about cassava. Cassava probably is from South America, but in either case, There were several annuals and geophytes domesticated. They show up in the early archaeological sites about 10,000 years ago. And another key point here is that both of these kinds of plants are adapted ecologically to seasonal climates. The annual plant, such as the wild oats in the Berkeley Hills, completes its life cycle within 12 months. It goes from seed to seed. It depends upon seeds for reproduction. And it's the seeds that are valuable to people, of course, because the seed or grain is a little package of energy, carbohydrate mostly, but also some protein. And people took advantage of these resources in the process of domestication. Geophytes are the same way, and although in a different mechanism. The tuber is an adaptation to a seasonal climate. The tuber is sort of a storage device that builds up in the ground during the growing season, and it's sort of energy in the bank that sits out the then following unfavorable season where it's too cold or too dry, and gives the plant a chance to really take off when conditions start up again in the spring, for example, when conditions are favorable for growth. So it's sort of another adaptation to seasonality. And it's no coincidence then that all of these four centers are located in areas of strong seasonal climate. Mexico, we see in the satellite image here. I'm sure most of you are familiar with the basic geography here. Well, I'll talk more about the climatic differences in the middle, but there's a big contrast between the highlands here that are flanked by mountain ranges, the Sierra Madre Oriental, and the Sierra Madre Occidental, and the Sierra Madre del Sur, and then the Mesa Central, the plateau here, and then the tropical lowlands in the east, over towards the Yucatan. Now, the next set of maps I'm going to go through very quickly. I've got 12 maps, and each map represents a month of the year. And we don't have to worry about all the numbers here, but what these maps are showing are the monthly amounts of precipitation for North America and Mexico during the year. These are the average monthly values. And as you might expect, the darker the green, the wetter the area is. So we're starting in January, the first month of the year. And I'm going to advance through the next 11 slides to give you the whole annual cycle. So the lighter areas, remember, are dry, and the green areas are wetter. The arrows are the wind directions. So it tells you where the moisture is coming from. So here we're in February, March, still dry in Mexico, notice. That's the winter, the dry season in Mexico. April, May, notice it's getting wetter down in Central America. June, now we're in the rainy season in Mexico. Mexico has its rainy season in the summer, just the opposite of California. And the rains last for 3 to 4 months, depending where you are. Here we're in August, and then it starts to move backwards the other way until we get to November and December, and we're in the dry season again. So this is just to emphasize the point that Mexico has a strongly seasonal climate regime, especially with respect to precipitation. And you see the same thing here in the graph, or graphs for one station. This is a place in the Sierra Madre del Sur. I'll talk more about it later. Teloloapan in Guerrero, and the green circles show the monthly precip values, the averages. You can see the dry season again here, the rainy season in the summer. Notice the evaporation has a different curve. A lot of evaporation in the winter. This accentuates the dryness of the environment. And then evaporation drops when the rains come. The temperature actually drops as well. And for at least 4 months, there's more rain than evaporation. This is the time period during which, the summer 4 months, during which the domesticated plants grow and mature. And I include Teloloapan here because it's a place very close to where corn was probably domesticated. And we'll get back to that in a minute. But just to reinforce the climate context here, this map, you probably can't read the label here, but these are, again, rainfall values expressed on an average for the year. And the browner colors represent drier conditions, the deserts of the north, right? And then the blue and green, the wetter areas in eastern Mexico and Tabasco, Chiapas down here, and along the coast of the Pacific. Corn, actually, since I mentioned before, I've mentioned it again here, obviously it doesn't do too well without irrigation up in the north here. Much of Mexico is very dry, too dry for rain-fed corn agriculture. In fact, you need about 600 millimeters a year to get a good corn yield. So that value is in here somewhere. The lightest of the greens marks the limit for the rain-fed corn agriculture. So it's too dry up here, and actually, paradoxically, it's too wet down here. In the lowlands, where you can get 2,000 millimeters or even 4,000 millimeters of rain a year, those very wet conditions can be detrimental to corn agriculture. And here's a map just showing modern land use, basically, and I've just labeled two of the categories. We're not worried about everything here. It's in Spanish. As you see, the dark purple represents irrigation agriculture, and there are a few scattered areas along the central volcanic axis, as it's called, this area where all the big volcanoes are. You've got several alluvial valleys, lake margin areas where the water table has been used to pump water out to grow crops. And then the lighter purple, the larger area, is rain-fed agriculture, or as they call it down there, temporal, where the farmers depend upon the rain. There is no agriculture. So this gives you an idea of where agriculture in the two different categories takes place today. And now I thought I'd move over just to give you some background on three important characters here, the three sisters, as they're often referred to as, the three big crops in Mesoamerica: corn, zea mays. Corn, by the way, is the name that the Europeans gave to, they called it Indian corn in the eastern United States during the colonial period because it sort of looked like wheat, although not very closely, but it's a cereal, so they called it corn. Corn originally, of course, is an old world term. Maize is another name often used. That's a term, a label from the West Indies. In Mexico, the Nahuatl speakers call corn Sintli. We'll get to that later. Beans, another important domesticate, Phaseolus vulgaris, the common bean, was domesticated in Mexico, and of course squash. There are several members of this family that were cultivated in Mexico, but perhaps the most important in terms of agriculture on a larger scale is this one, Cucurbit pepo, what we call the pumpkin, right? The pumpkin, Halloween. And the next few slides just show you where these plants were probably domesticated. These are estimates based on archaeological evidence, especially from cave sites. A good article by Smith that I'll perhaps pass on to you if you're interested to look at a review of all this. And he points out that there were three areas of early domestication for the three sisters. The beans in west central Mexico, here over in the state of what is now Jalisco there. And then corn in Guerrero, in the Rio Balsas drainage, and down here in Oaxaca, squash shows up at a very early date, about 10,000 BP. You can see the dates here, 10,000 BP for squash in Oaxaca, somewhat later Tehuacan here, not Teotihuacan, and progressively younger dates as you go north, as the crop is taken to the north. Maize a little bit later than squash, and bean very much later. Beans are not very well represented in the archaeological record. They don't preserve very well. They're not found very often. So the record is rather incomplete there. But this next slide shows the site where the squash remains were found. It's just a little cave here in the side of the cliff there, a place called Guilanaquits in Oaxaca. And it was here that the archaeologist Flannery found all sorts of plant remains, including this seed on the right here, which was later dated by Smith to be 8,900 radiocarbon years old, or 9,000, that's about 10,000 actually. It's, when you convert radiocarbon to real years, this is about 10,000 BP. And it's a familiar thing, right? If you open up a pumpkin, you see a lot of these seeds. Here is an image of the modern Cucurbit of Pepo from that same area, Guatemala, and adjacent Oaxaca. And the author of that study believes this actually is the modern descendant of that early domesticate. And it's got the ribbed appearance here, as you can see. These are ripe. They turn yellow when they're ripe. But you buy squash in Mexico City, you'll typically see this kind of squash. It's sold when it's green, calabaza, which of course is a Spanish name, or perhaps Arabic, I'm not sure. These are the Cucurbit of Pepo fruits that you'd buy in the market in Mexico City. I won't get into the complex taxonomy of Cucurbit of Pepo. There are many different varieties of Cucurbit of Pepo, and they often look very, very different. The zucchini, for example, is a member of the same species as the Halloween squash. You might not think so, but it's the same species. And the ornamental gourds that you buy at Halloween, they're the same species as the pumpkin. They'll hybridize and produce some strange combination effect. But anyway, this squash was probably domesticated from the ancestral group that produced this wild plant. Cucurbita fraterna is a wild squash that grows in northeastern Mexico now. The pepo, as was indicated on the previous slide, refers to the fruit that sits below the flower here, you see, with the stigma and the anthers. People, of course, eat the flowers in Mexico as a vegetable. Cucurbita fraterna is not a common wild plant, but it does grow in this northeastern part of Mexico in Tamaulipas. We needn't worry about the other areas. I just wanted to show you the present-day wild relative is found. At least that's based on genetic evidence. When you compare the genetics of Cucurbita fraterna with the genetics of Cucurbita pepo, you get a very close match. Now, I'll deal with beans very quickly here because there isn't much information, I'm afraid, as yet. But I took this photograph myself in southern Jalisco many years ago now of wild beans. And they just look like regular beans you'd grow in your garden. And this area is an amazing part of Mexico. A lot of volcanic activity in the past, volcanoes. This is in the dry season here, alluvial valleys. And the little town of Mascota is a beautiful little place out there off the beaten track in the southern Sierra, where I've been working for several years, coring lakes and working out the environmental history of the area. But just a few years ago, in 2009, a group of botanists from Davis, Quack et al. Here, produced a paper showing that it was this part of Mexico, this is where the previous slide was taken, this area here, is the part of Mexico in which the wild beans that are closest to the domesticated bean are growing today, and those are the purple circles. The green circles were also sampled, but they're not as close as the purple ones. So let me move on quickly to corn here. And I want to do this in a rather personal way, tell you a little bit about a very memorable trip I had into the southern part of the state of Jalisco many, many years ago now, as you can see, with an old professor of mine, Hugh Iltis, a famous botanist, very prickly character, but like a lot of brilliant people, you have to put up with them, right? And he published an article here, as you see in Science. It came out just after the trip, where he developed a new theory for the origin of corn. And for a long while, it was the #1 theory. It's since been rejected, I'm afraid, sorry to say, but part of it is still valid. And the important part is that Iltis stressed that corn is the domesticated equivalent or derivative of teosinte, this wild grass that we see in the image here. This is teosinte over here. This, of course, is corn, the familiar corn. This is a close-up of the teosinte plant with these are the male flowers up on top here, the tassel, and down below the cobs. The cobs in teosinte are very small. In fact, typically there'll only be about 8 or 10 or 12 grains in each cob. It doesn't have a well-developed cob like our domesticated corn, which we're all familiar with over here. But apart from the difference in the cob, the plants are very similar in appearance. And genetically, they're similar as well. There are several key differences, but it's accepted now that corn is derived from teosinte. And teosinte, by the way, means corn of the gods in Nahuatl. So the Aztecs, I guess, had got things worked out there 500 years ago, whenever. Anyway, this trip, to get back to the trip, we went part of the way, of course, by road, and here's my old VW, which I should never have got rid of because they're worth a fortune now. But eventually the road gave out, so we had to hire mules and horses and head up into the high country, and here I'm following Iltis, who's lecturing away as usual, pointing things out. Eventually we get up, not very high, but close to the summit of the pass, a little place called El Rodeo, just a few little houses there. And we went here because he'd heard reports that teosinte grew here. And so we did some exploration to try and find it. The people who lived here, by the way, all of the men had worked in California. Few of them spoke any English, but they all were more than familiar with the Central Valley and other parts of the state. This is a younger version of myself. I needed to lose weight back then, just as I do now. I think I wasn't much slimmer. But anyway, I've got in my hand there, you can't see it perhaps very well, but that's a teosinte plant here, the tassel up here. In other words, we found the wild relative. And it grows actually around, it grows in disturbed habitats around the edges of cornfields, for example. These are all teosinte plants. Superficially, they look like corn plants, but if you look at the cob, you can tell it's not corn. And here's a map showing the distribution of this particular type of teosinte. Actually, there are a couple of types of teosinte. The red is the one we found over here in Jalisco, and that's actually the wild relative. And there's another subspecies that's found up on the plateau, of Mesa Central. The black triangles represent its distribution. Initially, Iltis had hoped that teosinte was domesticated in Jalisco, where he spent a lot of time. But it turns out it didn't happen there. It happened further to the east in the Rio Balsas in the state of Guerrero. And we know that largely thanks to the genetics research of this group here and many others. And they looked very carefully at the genetic differences between many races of corn from the Americas. Each dot represents a sample they analyzed. These are all the domesticated corns. And then they also analyzed the genetics of the teosintes, the Rio Balsas type and the plateau type here, as you see. And the results indicated that it was the Rio Balsas type, technically it's called ZMA subspecies parviglumis. It's the same species as maize, but it's put in a different subspecies. So these green bars here represent individual specimens that were analyzed, and all of the bars are sorted out, so basically you work out the evolutionary tree, the family history of corn, maize, and how it came out of teosinte here. So the teosinte, the two types, the Mesa Central and the Rio Balsas, notice how Rio Balsas produces the early corns, and then as you go north and south, north into northern areas of eastern North America and south into the Andes, the differences become greater, and so the genetic relationship is further apart. But the results indicated that the populations of teosinte that gave rise to corn came from, as I mentioned, the Rio Balsas drainage. And paradoxically, the corns that they analyzed, the closest corn to teosinte you might think should be from the same area, actually is not. But it's from an area further to the east in the state of Oaxaca, not far from the cave I mentioned to you, Guilanaquitz. But first, just to give you an idea of the wild teosintes that are closest to corn, basal to maize, they say. This is that little town of Teloloapan. This is the Rio Balsas going down here. Acapulco is over here. And each circle represents a specimen of teosinte that was analyzed genetically and shown to be basal to the early corns. This is what this area looks like in the dry season. This is the Rio Balsas. And here we're probably in May here, looking north. Teloloapan is just off to the right. Yeah, I showed this before, but this bar here, I've put a black arrow in here to point out that number 25, the first of the corn samples, that is the closest corn to teosinte, the variety is known as Serrano Mije, and it comes from the mountains of Oaxaca here. Guilanaquitz you can't see very well, it's over here. This is a Google Earth image, as you can see, though. That's showing the Gulf of Mexico here, the coastal plain, some volcanic hills, mountains actually, on the coastal plain, the southern part of Veracruz. And then the Sierra Madre Oriental, and there are these high mountains where these people have survived, basically, in remote areas. This is the main mountain mass, the Mountain of the Winds, and a young girl here with a traditional dress. These people actually, this is a very different angle to this, but I thought you might be interested, speak a language that is close to the language that was spoken originally on the coastal plain. This is where we were in the mountains, the Oaxaca group. But the green areas represent a related linguistic group, the Zoque, and they're found in the Tuxtlas Mountains of Veracruz, which I showed you briefly on that Google Earth image. And there's also a group of them in Chiapas here. These are sort of remnant, relic populations of people who've been encircled by more numerous Nahuatl-speaking peoples, that sometimes refer to them as Aztecs, but the Nahuatl speakers, and of course to the east, the Maya become important as well. So my theory is that it was from the highlands of Oaxaca that corn was taken down into the lowlands, probably by the ancestral Mihe Zoque group. And in fact, when we look at lake cores and other lines of evidence, we can see that this is evidence for the arrival of corn at different places in the lowlands. Generally gets younger as you go east, but there are some reversals. This is a place where I worked, and this is where we were at Gila Nikits. Actually, if you average out the movement, it's rather slow. It's about a third of a kilometer a year on average. The movement from the highlands down into the lowlands took quite a while. It's about 1/3 the rate of the expansion out of the Middle East, for example, into Western Europe, where agriculture moved very quickly, relatively speaking, at about a kilometer a year. And I think the slow rate of expansion reflects the point that when you move down into the lowlands, the coastal plain and the Yucatan, you're moving into this humid tropical environment with significant precipitation in the summer. This is a vegetation map, as you can see, showing rainforests over much of the southern part of the Yucatan, Tabasco, and Chiapas. These are savanna areas, seasonally flooded savannas in the lowlands, and then oak and pine up in the highlands here, and fir. So it's a very different climatic environment, and actually would have been a problem for corn if people were trying to grow corn in the summer, because you remember corn evolved here up in the highlands in this summer rain regime, such as Teloloapan. But when you move down into the lowlands, this is the period when you get very heavy rainfall and high river runoff. The blue curve here is the river discharge for one of the big rivers flowing down onto the coastal plain, the Coatzacoalcos. And you can see it coincides very well with the precip in Teloloapan. But the problem for corn agriculture is you don't want to be cultivating when the river's high, because there's a risk of flooding, of course, and as we all know, this is an area where hurricanes are not infrequent. This was just a few years ago. You can't see where you are perhaps here, but the Tuxtlas are right underneath us here. Oaxaca's over here. It shows better on this map. Very heavy rainfall in just a few days. In the Tuxtlas, over 300 millimeters of rain in just a few days there. So this would have been difficult. This is what that area looks like, right where that heavy rainfall occurred. In the summer, you get flooding. The land is very flat, the coastal plain. It would have been risky to grow corn during the summer there. I think what likely happened was that corn became a winter crop, and people cultivated corn when the river levels dropped. In other words, during the dry season. And this is a cross-section that shows that idea. Here's the river. You've got the slightly higher ground next to the river with a few trees, and then marshy areas, tules. On these little ridges, when the river drops, you have a chance to cultivate, and the soils are very productive. It's sort of like the Nile, you know, the Nile floods, then it goes down. You get these very high yields. But this would have to be a winter rain crop. And I want to move quickly here so I don't run out of time, just to say a little bit more about what seems to have developed down in the lowlands. Here's the front page from a piece from a book in Spanish by a colleague of mine, Alfred Siemens, Tierra Configurada, where he's referring to the manipulated land or arranged land in the lowlands of Veracruz and southeastern Mexico. And he discovered through flying around in small planes that when the forest was cleared off, all of this area would have been forested only 100 years ago, but it's all been cleared for agriculture and cattle ranching. And now you can see these amazing patterns on the landscape. That is what he's referring to when he's talking about the configured landscape. These are called ridge fields. And there's been a big debate about what they really represent. They weren't apparently in use when the Spanish arrived, or at least not to any great degree. Some people think they're like the Chinampas of highland Mexico, which I'll show you in a minute. But I think more likely they are drained fields that were ditched to increase again the amount of time in the year that the ground surface will be dry enough to cultivate. This is simply a cross-section or block diagram showing how that might have worked. Okay, this is Los Tuxtlas, which we've mentioned before, and the lake that I've been working on and off. And this, I might add, is right in the middle of what's sometimes called the Olmec heartland. You see here. Here's the Tuxtlas. You've all heard about the Olmec people who produce these big heads and elaborate sculpturing, such as we see in the graphic. There are a lot of Olmec sites in this area of Mexico. Here's one that was found when they cut off the forest. They found this amazing evidence of a large settlement. The site is known as Laguna De Los Cerros. So we could have gone further here if we had more time. We could go further east into the Mayan lowlands, but I thought I'd come back to the highlands because I want to draw some parallels between what happened in the lowlands, the expansion down into the lowlands, perhaps slow beginnings, but eventually the development of large sites and population build-up to produce what we can call civilization in many ways. The Olmec are often referred to as the mother civilization of Mesoamerica. In the highlands, similar things happened, especially around the edges of these lakes such as these which occupied the Valley of Mexico, La Cuenca de Mexico is a more appropriate term. Mexico City is here, and the blue area represents the areas of lakes. These two are fresh here, and then this one is salty, like Texcoco. And this area in particular, I just thought I'd tell you a little bit about. We'll have to move quickly here because I'll be running out of time. This area was studied carefully by this woman, Christine Niederberger, who was an archaeologist who excavated sites around those southern lakes, just south of what is now Mexico City. One of them looked sort of like this in reconstruction. And eventually, the population built up here as it did in the lowlands, so that by 2,000 to 3,000 years ago, you have large sites and significant pyramids. Here's the famous circular pyramid at Cucurbit, just south of Mexico City, just south of the university campus, actually. It's a circular pyramid. It's sort of unusual. Here's my son showing off. It's also unusual in that it was nearly buried by a lava flow. This is a basaltic lava flow that came down about 2,000 years ago and overwhelmed the site. And according to some people, led people to move out of this area of the southern part of Mexico City, the basin of Mexico, up to the northern part, where, of course, you have the major classic period site, Teotihuacan, Pyramid of the Sun, the photograph everyone takes when they go there from the Pyramid of the Moon. And there's a question here, though, because this site, which some archaeologists think was occupied by as many as 200,000 people, was in one of the major cities in the world at the time, sits in an area where the rainfall is barely 500 millimeters a year today. It's very, very dry. And so there's a puzzle as to how on earth this large population was supported. There must have been more than just local agriculture, unless the environment's changed dramatically and it's got significantly drier. There must have been some importation of food to sustain this very large and impressive city, which, of course, as you probably all know, was abandoned about 500 to 600 AD. And then later, of course, the so-called Aztecs, or Mexica is a better name for them perhaps, arrive and set themselves up in the middle of the big lake here at the city of Tenochtitlan. Here's an artistic reproduction of it, showing the volcanoes in the distance to the east, Popocatépetl and Iztaccíhuatl, and causeways connecting the city to the area around. This site also was very large, not as large as Teotihuacan. It was over 100,000 people, though, probably at its peak when the Spanish arrived. And again, there's the question, how on earth was a large city like this supported agriculturally? Most people think, in part, it was supported by very intensive agriculture down in the south here. This is the map showing this area. Here's Tenochtitlan. Here's Teotihuacan up to the north, as you can see. Tenochtitlan in the lake. And then in the south, the two freshwater lakes, Xochimilco and Chaco. And it was around the margins of these two freshwater lakes that this very intensive agricultural system developed, basically during the late pre-classic and the classic periods. And you might have heard about them. Perhaps the best example we have of extremely intensive agriculture in the prehistoric New World, certainly in North and Central America, the Chinampas of Xochimilco and Chaco. A study carried out by Pedro Armillas in 1971, he mapped out the distribution of the Chinampas then. They were still in use. There's still a small area in use today, but very much less than this, I'm afraid. But not too far back, the earlier part of the last century, much of this area was intensively cultivated with this Chinampa system. Chinampa, by the way, simply means raised field or field grounded on tules. There are various definitions for it, but here you see a good example of what the situation is like. The men here, or Chinamperos, are canoeing down a canal, and on the side of the canal you have this raised area protected by willows. See it better here, perhaps. These are willow trees. And then the planting bed, which is several feet, a couple of meters perhaps, up above the level of the canal. And what happens here is the Chinamperos take the silt from the bottom of the canals. The canals are artificially constructed, of course. They dredge the silt from the bottom of the canals and put it on the flat surfaces. And of course, it's very productive. Not a lot of nutrients the plants need. And then they take care of the plantings very carefully. Here you see individual irrigation, watering, and they use special techniques to increase the yield. They will use forcing beds. They plant the crops in little boxes or areas of mud, and you can see the little holes here where they've stuck the fingers in, they drop the seed in the hole. These are called chapines. When the plant matures enough to take off on its own, they'll cut out the plant and put it into the field so it can, into the chinampa, that is, so it can grow on its own. This area of Mexico is sensitive to frost. In winter, they get occasional frost, so they protect these planting beds with mulch, as you can see here. Now, here's another area of chinampa and corn on the edge of the chinampa. These fields are not normally planted in corn because corn's not a big financial rewarding crop. They plant more valuable crops, including flowers still. In fact, the name Xochimilco means a field of the flowers in Nahuatl. And that tells us again that the Aztecs were doing the same thing. They were planting these areas not simply in food crops, but also in ornamentals. And this very intensive system of agriculture, I would say, is not technically agriculture. It's closer to horticulture. It's gardening. It's not the European style broadcasting seed and using the plow. This is very intensive farming where the farmer knows every plant in the field. I remember distinctly when I was down here, I asked the local farmer if he'd ever seen any teosinte, because teosinte, remember the wild relative of corn, does grow in this area. And he said, yes, yeah, I know. There's some teosinte in here. And he went over and went to the edge of the field and picked up just a little seedling like this. And he says, yeah, look at this. See the teosinte grain there? That's teosinte. That's not corn. This is a sort of triangular shape. It's different from corn. I said, how on earth did you know that was teosinte? It looks just like corn to me. It's got the same leaves. He said, it's simple. I know it's teosinte. I didn't plant it there. It planted itself, right? In other words, he knew every plant in the field. And the yields here, if you're interested, these are gourds here, maize in the background. It's reported that you can get as much as 10 tons of corn off a hectare. And this is a very impressive yield for corn that equals and is higher than yields in the corn belt of the Midwest. I think I can say that with some certainty. It's certainly a lot higher than traditional agriculture in Mexico today, where you're lucky if you get a ton per hectare. You know, a hectare, 100 meters by 100 meters. You get a ton of corn, that shell corn off 100 meters by 100 meters, you've done pretty well. But here, they can get as much as 10 tons if they want. And they don't often plant corn, though. They plant cabbages. And here's another. This is a green here, quelite. This is a native species. This is introduced, of course, from the Old World. And then on the right, this is away from the Chinampas, but just a mile or so down the road. Here the farmers planted amaranths, or huautli, the Nahuatl name. This is a plant, some of you may know, you can buy amaranth now in the stores, Andronicos and other places. It's getting popular. A small grain, very nutritious. And it was a big popular crop with the Aztecs. This Chinampa system is on the way out, actually, because the hydrology of the area has been dramatically transformed. Water tables have dropped, contamination, pollution, make it too risky and too difficult to cultivate with this system of agriculture. So the area of Chinampas is getting smaller and smaller. These are fossil Chinampas at Xochimilco that were abandoned because of these reasons. So just to sum this up then, I put a few points together here. The first point I didn't elaborate on, but you can think about it. How is it that it happened more or less the same time as in other parts of the world, at least 3 other parts of the world? The expansion was slow in the beginning, especially towards the east, probably because of these climatic differences. And I haven't mentioned the problem they had of the limited number of domesticated animals. There are only 2 domesticated animals, depending how you define it, but in Mesoamerica, right? I've just forgotten. I'm joking. yeah, the turkey.
I said chicken. Chicken.
Oh, well, the Aztec chicken. You mean the turkey? Yeah, chicken's from Southeast Asia. Yeah, the turkey and, of course, the dog. And they ate both of them. Dog eating was part of the diet. The hairless dog. That's another story I have to come back later for. Anyway, the development of what we can call civilization, large urban centers, comes relatively late in Mexico, but it did happen around 3,000 to 4,000 years ago, both in the lowlands and in the highlands. And and as I suggested with the Chinampas system, some of the agricultural systems used were very sophisticated and very productive, certainly on a par with anything from the old world. And now, of course, several Mexican domesticates are important crops in other parts of the world, particularly, of course, corn, which is of tremendous economic significance. So these are some of the main points I thought of. You're all teachers, I know. Most of you are from California, I assume, right? Yeah. So when you teach, I'm sure you have a significant number of Hispanics, Latinos, or whatever we call them, the people from south of the border these days. It occurred to me this kind of discussion would be a good one for an Hispanic class, because it will give them something to feel good about, right? In other words, there's all this criticism of people coming across the border illegally and so on. Agriculture came across the border illegally here with these domesticated plants many thousands of years ago, and Mesoamericans have still not got paid for the benefits that these crops have produced, right? So I think it's a good theme for California to stress the positive here and make the point that some really important things happened south of what is now the border, and they shouldn't be forgotten. Okay, I'm preaching. I'll leave it there. Thank you.
Thank you.
Yeah.
Is teosinte ever used as a crop? Is it eaten?
Sorry?
Teosinte, is it ever used as a crop?
Good question. No, it's used in parts of the United States as a fodder crop, just for to feed cattle with, and in Mexico as well, perhaps. But the grains are so small and so tough that it's not used for the grain. It has very little nutritive value. It's just not worth it. That mystery of how the teosinte cob becomes the corn cob, geneticists are still working on. But it is valued, though. The farmer, as I mentioned, at Xochimilco, knew about teosinte, and you let it grow there. They allow teosinte to grow in their fields because they feel it strengthens the corn. It does it does exchange pollen with the crop, the corn crop, and that is thought to help certain lines of resistance. You know, it's a wild plant that, in that sense, is beneficial, but it's not cultivated for its grain.
So
yes.
When we talk about teosinte being the sort of ancestor of corn, the implication when you look at it is that people cultivated that and ate it. And there seems to be nothing there. So when you
Yeah.
see that plant,
Yeah.
is that not true? Did they not use the plant as a food crop?
Well, eventually they did. But that's another good and tough question. I think the early teosinte, as it became transformed into corn, would have had a lot more in the way of cobs than the present-day modern corn plant. In other words, it could have had a lot of relatively small cobs, but more of them. In fact, in the archaeological finds of early corn, where it's obviously no longer teosinte, the cobs are only about 2, 3, 4 centimeters long. But if you have a branching plant with producing dozens of these, then conceivably you could get a useful yield from them. But that's how that actually worked is still not understood. Yeah. Yeah. Yes.
Is there any evidence of contact between these agriculturalists in the Mexico area and the ones in the Andes? Like, did anything go back and forth?
Yes. Well, there certainly was contact, especially along the Pacific coast. And corn does go down there. I forget the latest date. I think it's 4,000 or 5,000 years ago. It was already in Peru, northern Peru, and eventually it got way down to Chile by about 2,000 years ago. So there was contact in that way. There doesn't seem to have been a lot of contact in terms of crops other than corn that I'm aware of going the other way. For example, potatoes, what we call Irish potatoes from Peru, weren't introduced into Mesoamerica, or tomatoes, for example, weren't introduced. And the squashes they have down there are different. So there was some connection, but it wasn't a very powerful connection. In fact, each of the centers had somewhat similar but different set of domesticated plants. Like they had amaranth-like plants in the highland areas of the Andes, as well as in Mexico, but not the same species. And they had beans, for example, lima beans, and even had Phaseolus vulgaris, but it's thought they were not taken there by people, but rather separate. Yeah.
How are the Chinampas constructed?
Well, it's basically you dig down a canal, excavate a canal, and then pile up the sediment to the sides. So you build up the surface of the land on the sides of the canal, and that way you reduce the risk of flooding. Because this area, and I can tell you having lived down there for over a year in that area of Mexico City, in summer you can get dramatic floods there in a short period of time. So you don't want that, obviously, if you're a farmer. But if you raise the ground, a couple of meters, you don't want it too high because then it makes irrigating more difficult. But if you get the balance right, you get a planting surface that minimizes the flood problem and also gives you access. The canals can be easily navigated, right? In fact, the canal system went all the way down to Tenochtitlan. So, yeah.
You mentioned that they could produce 10 tons per hectare.
Yeah.
Is that contemporary, or like how far back is that?
Well, that's based on historical evidence. Yeah, that's based on, I think, colonial period documents. There might have been experimental studies done as well. I'm not aware of it. But that's one number that sticks in my mind, that it was a pretty impressive system in terms of how much you could get off a particular area of land. Yeah. Yes?
I just wondered about, I remember hearing about corn, squash, and beans grown in the same
Yes.
plot together, and I wondered, is that a different style of thing than the one that you just showed that was intensive? I noticed when you were showing that things were planted in rows.
Yes.
And I was curious about that because I always felt like planting in rows is a conscious choice that's not necessarily, like it seems to have a lot to do with having a plow.
Well, yeah, good point. I think the that contemporary situation is a mixture. There's been some Western influence, obviously, and some Western crops are cultivated, like the cabbage I showed. So it's not the truly traditional system. And it is the case that the three were planted together, typically. As you've heard, the squash provides the ground cover, minimizes weed problems. The corn is a sort of support for the beans, which, of course, are vines. So it's a nice package deal. In contrast to the European, Middle Eastern agriculture, where you just grow wheat or barley and that's it, right? So, yeah, multi-cropping is more typically the way it's done in the New World tropics, and even in higher latitudes in eastern North America as well. Yeah. Yes?
Yes. I was in Guanajuato many years ago, 10 years maybe, and there was a festival that just happened in August when we were there. They let some water out of the canal before the rains, and there was a big picnic, and they said it was a ritual that happens every year.
Oh, yes?
Yeah, they call it echar el agua al agua. I didn't know if it happens all over.
Well, yes, the water, of course, is very important in Mexico for agriculture, and it was important prehistorically as well. The rain god, for example, Tlaloc, and all sorts of things associated with trying to ensure that the rains came and there was no shortage, no drought. I haven't seen that. I've worked in Guanajuato, but I haven't seen the festival you're talking about. Of course, that's a big irrigation area today, right? The Bajío, and so the canals are part of that. And the in dry years, I guess the farmers have to make do with less, and so they're worried about that. Plus, the water table is dropping dramatically. They're about 1 meter every year. So, in a few years, it's going to be very, very difficult for that part of the world. Yeah.
I seem to remember reading an article about cassava.
Yes.
Tapioca. Is this grown in this area?
Well, not really. No, it is in southeastern Mexico, in the southern part of the Yucatan. Cassava, the evidence now looks like it was domesticated in South America. At one time, people thought it was domesticated in Mesoamerica because there are wild members of that group. This is manioc, if you don't know it. A root crop that's very important in the New World tropics and in Africa now as well. So it's a tropical crop, though, so it doesn't do well it's not cultivated in the highlands.
The article I read mentioned, and this is really going back in my mind,
Yeah.
there's something I read, that manioc or cassava produces so much more an acre than corn.
Yes.
So although corn is religious,
Yes.
manioc or cassava fed people.
Well,
I'm just remembering.
No, you're right. Yeah, well, that's true. Root crops generally produce a lot more in terms of mass per unit area, right? Because when you think about it, a field of potatoes is going to give you tons and tons of potatoes, right? Because the crop is so productive. But on the other hand, it's all carbohydrate, and it's although it can be, these tubers can be stored in the right circumstances. There's sometimes a problem with storage. Whereas with corn, if you keep it dry, you can store it for long periods of time. And it's nutritionally, I think, better per unit mass than cassava for you. Plus, it tastes a lot better as well.
I'm trying to remember, I think this article said that preparation
Yeah.
of manioc is really difficult.
Yes, yeah.
It's poisonous or something, and it's, I'm just remembering. I'm
Yeah.
sorry.
Well, one type of cassava is poisonous. If you don't leach out the cyanide, then you can get seriously ill. Yeah. So,
And is that done by soaking it in water?
yes, soaking it. Yeah, like the acorns. Of course, that wasn't cyanide, but California Indians used to soak their acorns, right? Yeah, it's. But that poison, of course, is a defensive strategy on the part of the plant. It's sitting there in the ground. That poisonous compound presumably protects it against worms and other organisms that would likely chew it up if it wasn't poisonous. Yeah. Sorry. Yeah.
One of the debates that's currently around a lot in newspapers, say, at the moment, is whether, are we going to be able to feed ourselves in the new climate change period?
Yeah.
This threshold thing, and so you see lots of arguments between the issue of yield on using industrial style or a kind of tractor-driven agriculture versus traditional small farmer kinds of things. And currently, I think National Geographic has one on has a large issue on Africa this way, which is full of kind of mysterious conclusions. And I wondered about, given this sort of, if not only scholars but also if the Mexican agricultural community are thinking at all about the traditional, like levied agriculture and things that may have been abandoned, if that's if there's
well, this is a big issue down there, of course. Yeah. By the way, the Green Revolution started in Mexico. The CIMMYT, the Center for the Improvement of Maize and Trigo, wheat, is based just outside Mexico City. So, and that was started in the 40s with the Rockefeller Foundation money. So the development of high-yielding crops and the associated need for fertilizers and special situations, in a sense, starts in Mexico and is exported to other parts of the world. And it has that whole movement, the use of hybrid corn, hybrido they call it, has replaced traditional varieties in many, many areas, especially in the high yielding lowlands, the irrigated areas along the coastal plain and Sonora, for example, and in the Bajío we were just talking about. Up in the mountains, it's a bit different because there people don't have as much money. They can't spend a lot of money on fertilizer and hybrid corn. So they will tend to grow the old traditional varieties, of which there are many different types. Right? And there is some local, some of the university people are trying to encourage that way of doing things. The traditional systems are being encouraged and recognized as being valuable. People argue these people should get some subsidy for doing what they're doing because they're preserving genetic resources, you see. Rather than CIMMYT, where it was for a while, they have these big refrigerators where they collect seed and they put all the seed in the refrigerator and it sits there. That's their way of preserving genetic resources, you see. But the traditional farmer up in the Sierra is doing the same thing, but in a sort of living way, which I think is better.
And if corn comes from the highlands, there's some sort of justice in the cycle of corn, keeping corn going.
Oh yes, yeah. But the problem, the other bigger problem down there, and it's true for many areas of the tropical world, is because the population increase has been tremendous. And whereas Mexico used to be self-sufficient in agriculture, 20, 30 years ago, now it's definitely not. They have to import corn from the United States. It's just, it's too late. In other words, the traditional systems can't support 120 million people. There's absolutely no way. Yeah.
And so when you talked about the sort of intensive, the yield being more intensive in certain ways than it is in others.
Yeah.
The high-tech farming kind of yield thing trumps.
Well, they also get fairly high yields because of their input in terms of fertilizer and and irrigation, and yeah, but there are costs associated with that, as we all know, that aren't always expressed in the budget, right? In
Case study for the
yeah,
world, right?
yeah. So it's a complicated and difficult issue, but I certainly I'm sympathetic with obviously the idea that these traditional varieties, which if they are lost and replaced by hybrid corn, that's a big, big loss, right? Because they've been around for hundreds, even thousands of years.